All right, looking at our due now, we see that Laura is getting ready to go to college. $45,000 per year is how much it costs for her to go to college. Thanks to some hard work, the school is offering her $9,000 of scholarship. What percent of her tuition is covered by her scholarship? So, thinking about this, we have our quantity is equal to our percentage times our whole. As we read here, it says what percent of her tuition. So tuition is going to be our whole. That's 45,000. And our quantity, the quantity is the $9,000 of scholarship. So we're trying to figure out what percent that is. So this makes sense. This is divided by 45,000. Divided by 45,000. And if I think about this, I can really think about this as 9 divided by 45 in order to kind of make the math a little bit less complicated. And when I do that, I'm going to get 0.2 is equal to the percent, which is 20%. All right, let's flip on over and look at our work for today. All right, today's aim, Kipsters will be able to use quantity equals percent times whole to solve markup and mark down problems. Mark down problems. So what do I mean by markup and markdown problems? Well, this is just discount problems and problems where people have increased the price by some percent. And so this is really all the consumer math that you are pretty familiar with already. All right, so Games Galore Superstore buys the latest video game at a wholesale price of $30. So talking about wholesale price, when a manufacturer makes something, they sell it to the store for what we call the wholesale price, and then the store marks it up so they can make some profit to sell it to you. So in this particular case, the manufacturer makes the product and then sells it to Games Galore for $30, and then Games Galore is going to mark up the price 40% so they can make some money. You use your allowance to purchase the game. How much will you pay, not including tax? So looking at this problem, they have marked up the price 40%. So you're not just going to pay at the store the $30, but in addition, you're going to pay an additional 40%. So thinking about this is like a percent increase of 40%. So go ahead, write an equation, a single equation that you could use to solve to find out what price you will pay at the store. So stop the video right now, work with your partner, make sure that you've got an equation written down to do this. So the equation we're looking for is that our quantity is equal to percent times whole. In this particular case, we're looking for the final quantity, so we're looking to use a final percentage. So again, thinking about this is you're paying the $30, that's 100% of the whole, plus you're paying 40%, that's another 40% of the whole. So that's the quantity is equal to 140% of the original price. All right, go ahead and use this space down here to solve that equation. After completing this on your own, let's check back in. We see that this is 1.40 times 30. 1.40 times 30 is going to give me $42 even. So the quantity is equal to $42. So what was the total markup of the video game? So it's asking me for just the markup. This is asking me for just what the change was. So considering the work we've already done, this is really easy. What is the total markup? So what's the difference between how much they paid wholesale and how much you pay? That's the $42 minus the $30. 12. All right. So a $300 mountain bike is discounted by 30%, and they discount it an additional 10% for shoppers who arrive before 5 o'clock. So when we talk about this, we see that there are two discounts. One thing I want you to discuss with your partner, consider the situation where you have a coupon for 50% off, and then you find an additional coupon for an additional 50% off. So you've got two 50% off coupons. Turn and talk to your partner. Will the store give you the item for 100% off or absolutely free? So if you had two coupons for 50% off, turn and talk to your partner. Would they give you the item for free? Would they just let you walk out the door with it? All right, having had that discussion with your partner, the answer is no. The store would never just let you walk out the door if you had a 50% off coupon and then an additional 50% off coupon. What would happen is they would apply the first discount, give the new price, and then give you the 50% off of the new price, which we're going to find here in a second is not going to give us the same thing as 40% off. All right, so a $300 mountain bike is discounted 30%. So we're going to look at this. Quantity is equal to percent times whole. The quantity is equal to our percent. Now, this is again looking for a final amount. Our percent here is going to be if we had 100% of the price and we take away 30% of the price, we're left with 70% of the price. And our whole is the original $300. So this is kind of a percent change problem, but again, we're not looking and talking about just the percentage of the change. We're looking for that final amount. So 70% tells me the final quantity, the final value of the price after the first discount is going to be $210. Now, we're given an additional 10% off, so the quantity of our final is equal to our percent times our whole. Now our new whole is that the price was $210. But then we took an additional 10% off. When we take the 10% off, we had 100%, we take off 10%, we're left with the price to pay is 90%. So that gives me 0.9 times 210. So our final price that we pay after the two discounts is equal to $189. All right, so we can see that when we have two discounts or markups, we need to apply one discount or markup and then the other. All right, in all, by how much has the bicycle been discounted in dollars? By how much has the bicycle been discounted in dollars? So you should be able to figure that out with your partner. Look at the final price that we ended up paying down here after the second discount and the original price and figure out how much it's been discounted. So the price was $300 minus $189. It's going to tell me that the final price was discounted $111. All right, after both discounts were taken, what was the total percent discount? All right, so this is where we want to go back and we want to look at this is what is the percent of, what is 111 as a percent of the original price, 300. So quantity equals percent of whole. Our whole would be the $300. The quantity that we're finding a percent of is 111. Do the division. And after we calculate this, we're going to get 111 divided by 300 is going to be equal to 0.37, or 37%. So looking back at this, we had a 30% discount and then a 10% discount. Turn and talk to your partner. Why is this not exactly going to be a 40% discount? Think specifically about the second discount. All right? Have some conversation about why this may not be exactly a 40% discount when we apply 30% and then 10%. All right, so having had that conversation with your partner, let's think a little bit more deeply about this. So the 30% comes off of 300, but the 10% comes off a smaller number. So it becomes off a smaller number, your discount from that is going to be a little bit less than it would be if it came off the original $300, right? Because that percentage of that whole is just not going to be as much because the whole is not as much. And so as a result, what we do see is that we end up with something down here where on a double discount or a double markup, the change is just a little bit less. All right. Sasha went shopping to decide to purchase a bracelet for 25% off the regular price. If she receives an additional 5% off for figuring them out today, find the sales price and how much money she will save. So the first thing that you need to do is go ahead and find the sales price of the set of bracelets after both discounts, and then find out how much money she saved. After seeing the previous example, you and your partner should be able to do this together. So go ahead and pause the video and complete this problem on your own. So looking at this, our quantity is equal to percent times whole. Again, we cannot just add those two things together. That's just not how it works. They're not going to give you 100% off if you had 50% plus an additional 50%. Our percent times our whole. Well, our whole is the original price. And I apologize, our graphic did not make it on there. Our whole price for this is $44. That's on your page though. And our percent off is 25%. So if we take 25% off of the price, that means we end up paying 75%. That's what we're really worried about. Not how much is taken off, but instead we're worried about what would be that final price. So 75% of 44, the quantity we're going to get there is after the first discount, the price is $33. So now this becomes our new whole. So quantity is equal to percent times whole. And we're taking an additional 5% off. So if we're taking 5% off, what are we left with in terms of percentage? You should be thinking to yourself, 95% is what's left. The whole was 33. So what is our quantity after that? 95% times 33 is going to give me $31.35. Now this question does ask us to find the sales price of the bracelets after both discounts. However, it does also ask us how much money will she save if she buys them today. So make sure that you've done that with your partner if you haven't done that already. We can find that by taking the original $44 price and subtracting away to find out how much we ended up saving. And when we do that, we're going to get $12.65. All right. A golf store purchases a set of clubs for a wholesale price of $250. Mr. Edmond learned that the clubs were marked up 200%. Is it possible to have a percent increase greater than 100%? What is the retail price? So if we were to increase something by more than 100%, what does that mean? If I add 100% of the price to the price, what would that mean? Turn and talk with your partner. Make sure that you've got some thoughts in your head about what that would mean. So thinking about this, if I have something, let's say it's $5, and I add an additional 100% of the price, so that's 100% plus 100%, that would be 200%. I'd actually be doubling the cost. All right. Additionally, if I made it 300%, or I marked it up by 200%, 200% plus 100%, that's going to be 300%. If I change that to a decimal, that's going to be times 3. So that's what we're going to see here in our example. What is the retail price of the clubs? So quantity is equal to percent times whole. Well, our whole that we're starting with is our original price of $250, and we're marking it up 200%. Well, we're going to pay 100%. We're going to pay the $250 plus an additional 200%. So when we start to look at this, our final cost on this one is going to be 300% of the quantity, which as we change this to a decimal, makes us recognize we're going to pay 3 times as much as the original price. 3 times 250. This gives us a price, the retail price of $750. All right. Is a percent increase of a set of golf clubs $250 to $750 the same as the markup rate is 200%? Explain. So let's quickly prove this. Quantity is equal to percent times whole. It says the percent increase. Remember when we're talking about percent increase, we're only talking about the change. Alright, so the quantity of the change, the price changed from 250 to 750. That's 500 times the whole. The whole price was $250. Divided by 250. Divided by 250. That's going to give me 2 is equal to our percent. Move it 2 times. That gives me 200%. Alright, so the percent increase is the same as the markup rate, and that's really important for us to understand, is that represents the amount of change. The 200% represents the amount of change, and thus is the percentage of change. Alright, let's flip on over to the other side. Alright, now we're going to be looking at some problems that are working backwards, but this should not be a major problem for us. Go ahead and find for me what percent of the original price of the car is the final price in this particular case. Now notice that what we have to do here is we have for this first part we're talking about just the price here, so 16% times 2,000. So there's a couple of different ways to think about this. One is to think about what is the percent of the original price that the car is. So this is answering, we're going to have to do this the way that it asks us to do this. So this is percent of original price is the final price. So go ahead and set that up into an equation and go ahead and solve it. Find out what percent of the original price is the final price. Do that on your own. Quantity is equal to percent times whole. This is percent of the whole, which is the original price, which is 20,000. And 16,000 is our quantity. To find our percent, we need to divide by 20,000. Divide by 20,000. And that's going to give me 0.8 is equal to 0.8 is equal to our percent, or 80%. Now, is this telling us that we have a discount of 80%? Think about it. Would it make sense that 80% of the original price would only be $16,000? So the answer to that is no. All right, so we pay 80% of the original cost. So what's the discount rate? So what percent was taken off? Well, if we started with 100% and we ended up paying 80%, then our discount was actually 20%. All right? So it says by law, sales tax has to be applied to a discount price. However, would it be better for the consumer to pay 7.5% sales tax before it was applied? Why or why not? So thinking through this, let's actually go ahead and see what that would look like. So as it is, we'd be paying, if we paid it after the discount, our quantity would be equal to 1.075%. So we're paying 7.5% extra on the whole price. The whole price after the discount is $16,000. $1.075. And if we plug that into our calculators, we're going to get that 1.075 times 16,000 is equal to 17,200. Now, if we do it the other way and we calculate the tax originally, quantity is equal to 1.075 before the discount. So times 20,000 is going to give us 21,500. So now this is the price that we would be taking the discount off of if we applied it first. So quantity is equal to 1.075 times 21,500. Alright, sorry, taking the discount now, so we're multiplying by the percentage of 80%, which is 0.8 times 21,500 is equal to also 17,200. So we can see that it actually doesn't matter. It's exactly the same. And let's talk about why that is. So in this problem, what we had is we had a value, 20,000, that was multiplied by 0.8. And then when we got that answer, we multiplied that, because we plugged that in for our whole, times 1.075. Over here, what we did is we had our original price, which was $20,000. You can see that we multiplied it by 1.075. And then we took that answer and we multiplied it by 0.8. When we start to look at these two expressions, what's different about them? Well, nothing's really different about them when we think about value, because the commutative property says we can multiply these in any order. So really, these are two equivalent expressions just used in a different order. So when we apply the discounts and the sales tax this way, it shows that it doesn't matter which one gets applied first. So it says to write an equation applying the commutative property to support your answer for part C. We've actually already done that. All right. Let's come over here and look at the last problem. It says write an equation to determine the selling price dollars P on an item that is originally priced S dollars after a markup of 25%. So thinking about this, I'm going to get you a little bit of help getting started on this one. So P, or our price, is going to be our quantity after the markup, and S, our original price, is going to be our whole. Go ahead and write an equation with your partner. So we should be thinking about this as quantity is equal to percent times whole. Again, if we're marking up the price, we're going to pay the 25% plus an additional 100%. So this is 125% of the whole price, which is P is going to give me, the original price is S is going to be P. So this tells me my equation is P is equal to 125%, move it 2 times, 1.25 S. Alright, so is create and label a table showing the possible pairs of the solution to the equation. So this is basically making a T-chart, and I'm doing a really ugly job here. Try this a little bit. Okay. Our inputs are our S, our outputs are our P, and let's plug in some values. Pick some values, whatever you want, and then go ahead and calculate for me what the P value would be. So maybe one price I might put in is $10. All right. I can see that it's going to ask me to graph the equation, so maybe I want to pick some values that are going to be a little bit easier to graph. So maybe picking smaller numbers and numbers that are closely together is going to be easiest. So I'm going to pick 10, 8, 6, 4, and 2. And I'm going to plug each of those in. P is equal to 1.25 times S. So for the first one, that's 1.25 times 10. And that's going to give me 12.5 or $12.50. And this one's going to give me 10. This one's going to give me $7.50. This one's going to give me $5. And this one's going to give me $2.50. So if I want to graph this, looks like I lost a little bit of my bottom down here. I'm going to plot this 0, and then I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are my original. And these are going to be my markup. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that top one's going to be 13. So let's go ahead and graph this. First one is over 10 and up to 12.5. 12.5 is going to be right up here between the 12 and the 13. 8, 10. So 8 and then coming up to 10. 6 and 7.5. So between the 7 and 8. And 4, 5. That's over 4 up 5. And 2, 250. And we can see that we get a straight line here. And this should make sense to us. This is a proportional relationship because we see that all we're doing is we're multiplying by 1.25. So 1.25 is actually our constant of proportionality. And we could go through and we could calculate that out. All right, so let's go ahead and flip on over to our alone time and let's get that work done.